Hello everybody, welcome to today's video. Last video, we were able to answer a problem about electric fields in one dimension. Now this time, let us try a slightly harder problem. First, let me erase my canvas. There we go. So the problem is as stated. Two charges are placed as shown in the figure. Let me just draw the figure right here. This is not drawn to scale, everybody. So this is 5 cm in length, 12 cm in length. This is a right angle, and 13 cm in length. There is a charge Q1 here, and Q2 here, and this is point P with an electric field going straight downward with the magnitude and direction E. So the problem is as follows. Two charges are placed as shown in the figure. The magnitude of Q1 is equal to 3.00 microcoulombs. Micro is 10 raised to negative 6. So the magnitude of Q1 is 3 times 10 raised to negative 6 coulombs. But its sign and the value of charge Q2 are not known. The direction of the net electric field E at point P is entirely in the negative Y direction. Okay, so there are three sub-questions to this problem. First sub-question is to draw every possible sign of Q1 and Q2 and their respective field lines. So let's say Q1 is positive first and Q2 is also positive. How do we draw the field lines there? Let me draw Q1 in red and Q2 in blue. So let's say these are our two charges. They will want to go away from each other. Like this, away from the home charge. Remember, Q1 is in red and Q2 is in blue. Sorry, I'm taking so slow to... Oh, that's a wrong field line. I'm sorry. It's a wrong field line. Okay. Okay, and the other field line. Sorry, my lines are not that straight. So this is what we will get. If Q1 were to be, if both charges were to be positive. So this is Q1 greater than 0 and Q2 greater than 0. Next case, we have Q1 less than 0 as well as Q2 less than 0. Here, the charges would want to point towards, the field lines, would want to point towards the charges. So let's just draw the field lines. That line is too long. Just draw the field lines right there. 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 That is wrong again. There and there. All of them are pointing towards each other. Towards the charge. And find that, sorry. Technical difficulties. Okay, there. So for blue, We have the same horizontal line base, like this, this, and all of them are pointing towards the charge. That is the second case. The third case is that Q1 is positive. This might be a long video. I'm sorry guys in advance. And Q2 is negative. Okay, so if Q1 is positive, the field lines would want to go away from each other. This time, look at it, it's a bit different now. Since Q2 is negative, it wants to go towards it. And there we have it. And now for our last case, Q1 is less than 0 and Q2 is greater than 0. Now it's basically just like this picture over here, but it's reversed. The directions are reversed. Let me just try to quickly draw it. Take note that field lines are not supposed to intersect, unlike what I just did. I'm sorry for that. Now for the blue charge, it wants to go away from it. Away from the charge, like that. Okay, those are our 4 cases. Now, there's letter B. As the second sub-question is using the using the sketches from the first sub-question and the direction of the electric field E, deduce the signs of Q1 and Q2. Okay, so we know that E is pointing straight down. Where do you think does E go? Well, one of the choices is that Q1 is less than 0. Both are negative, basically. One choice is that Q1 is less than 0 and Q2 is less than 0 as well. While the other choice is that Q1, look at here, this has somewhat of a going towards the negative y direction completely. So we could say that it's or Q1 less than 0 and Q2 is greater than 0. Here also you could actually see that there is, in this case, Q1 is positive, Q2 is negative. We could also see that there is somewhat of a negative y direction. However, it is below Q1. And as we see, this actually applies to both Q1 are positive. Both cases that Q1 are positive. We could see that P is going towards the downward Y direction, and it is above Q1. Let's say just above. So we are now just limited to both negative, or Q1 is negative and Q2 is positive. How do we resort to that? First of all, we could see that in order for this to be in completely the negative Y direction, it needs to be super, super, super close to Q1. So the distance to Q1 should approach 0. However, we would see that the distance between Q1 and P is 5 centimeters, which is not close to 0. In real life, it probably is very, very little, but it is not even close. So using the process of elimination, we can eliminate that, and our only answer is this. Q1 is negative and Q2 is negative as well. Now we go to the third sub-question, which is actually the hardest among all of them. Determine the magnitude of Q1, Q2, and E. So we need to find the magnitude of E, the magnitude of Q1, and the magnitude of Q2. Well, we already know the magnitude of Q1, which is equal to 3 times 10 raised to negative 6 coulombs. And that's actually one of our answers already. But now we're just gonna look for the magnitude of E and Q2. How do we do that? Well, first, let's go over some trigonometry. Let's redraw the triangle. That's not good. Let's redraw the triangle. Just connect that right there. That's connected. This is a right angle. This is 5, 12, and 13. All of them are in centimeters, so I won't place in the unit anymore. You see here Q1, Q2, and P. Now, if we kind of rotate it a bit, I don't know how to rotate the figures using Microsoft Whiteboard. I'm sorry. But if we rotate it, we would see that it is actually already a right triangle. Or just by looking at this right angle, we would know that it's a right triangle. Now, we can assign this to be theta and this to be alpha. Now, we would be needing these values later. Cosine theta, cosine alpha, sine theta, and sine alpha. We could use our basic SOHCAHTOA to get this. So cosine theta is equal to, cosine is adjacent over hypotenuse. So adjacent side is 5 over 13. Cosine alpha, adjacent side is 12, hypotenuse is 13. Sine theta, opposite is 12, hypotenuse is 13. Sine alpha, opposite is 5, hypotenuse 13. Alright. Now we move on to redrawing something a bit. So let's say that this is a horizontal line passing through point P. This is point P. So the electric fields, this is E1. Since we already deduced that both of them are negative, meaning both of them should be pointing towards each other. So this is E1, points towards Q1 in that general direction. This is E2, it points to E2 in that general direction. Now, what direction exactly? As you can see here, let's draw a horizontal line which is parallel to this. So, by alternate interior angle theorem, Let me just move this 5. Okay, it's better. So we would get alternate interior angle. We will get this angle to be theta as well. Therefore, this angle should be alpha. That will also apply here. This angle is theta. This angle is alpha. Okay, so we have our two directions already. Now we could, since both of them are angled, we should place them in the appropriate, separate them into their appropriate components. Now we know that this is E total. It's only in the negative y direction. So x components should be cancelled. So here we see the magnitude of E2 in the x component minus the magnitude of E1 in the x component should be equal to 0. Now let's try to solve that first. E2 is k q2 over r squared. R of q2 is equal to 12. So actually, not 12, it's 0.12. We square this, and since it's x, we say cosine, and the angle that we're going to be using is alpha, minus kq1 over r1, which is 0.05, squared, x is cosine, and the angle should be theta. That's equal to 0. Now we can't cancel the cosines because the angles are different. But what we can do is multiply both sides by 0.12 squared times 0.05 squared. We would get, actually, no. What we could do is place kq1 cosine theta over 0.05 squared on the other side. We'll get kq2 cosine alpha over 0.12 squared equals kq1 cosine theta all over 0.05 squared. We could now cancel the k's because it's a constant anyway. Multiply both sides by 0.12 squared over cosine alpha. We would get q2 is equal to 0.12 squared q1 cosine theta all over 0.05 squared cosine alpha. Now we already have cosine theta and cosine alpha in our list here. So just substitute that into your calculator. We would get q2 is equal to, or the magnitude of q2, the magnitude of q2, since we already have the magnitude of q1 as well, magnitude of q2 would be equal to 7.240 times 10 raised to negative 6 coulombs. This is just the magnitude as the problem is stating. Now, we already have the magnitude of q2. Let's look at the magnitude of E. Now, we could see here from this diagram, let's move it here, E2, the magnitude of E1 in the y direction plus the magnitude of E2 in the y direction, that would equal to E. This is what we want. E is what we want. So we would say that K is the magnitude of Q1 in the y direction, so sine theta all over r squared, which is 0.05 squared, plus K times the magnitude of Q2, again, sine, but this time alpha, all over 0.12 squared equals E. we already have all the values that we need here. K is a constant, sine alpha and sine theta are already available to us. And finally, we already have Q2, which is this, which is 7.240. No, I'm sorry. I misread what I wrote down in my work. I did this on paper before. I initially did this on paper first. So this is 7.2 times 10 raised to negative 6, not 7.240. It's just 7.2. I'm sorry for that. So magnitude of Q2 is 7.2 times 10 raised to negative 6 coulombs. Place all of these in your calculator and we would get the magnitude of E is equal to magnitude of E would be equal to 1.17 times 10 raised to 7 newtons per coulomb. That is our final answer. So if you learned something new today, you could leave a comment down below in the comment box. And please also like and subscribe if you like the video and you would like to learn more things about electronics and other physics and chemistry stuff on my channel. It would really help me a lot. And as always, thank you and have a nice day.